Alright, this video is going to go over the second review quiz for the semester exam. This covers Chapter 10 and 11. Chapter 10 was about trig identities, solving equations and doing proofs, and Chapter 11 was the stuff we just did, polar graphs, polar equation, polar versions of complex numbers, and so forth. Okay, so it should be freshest in your mind, but I'll go over these real quick. Number 1 says find 1 plus I to the 12th. The first thing we want to do is write this number 1 plus I in polar form, and so if I do that, this distance is 1, this distance is 1, and this is root 2. This is a 45-degree angle, or pi over 4, and so this number could be written as cis root 2 cis pi over 4. I'm taking this and I'm raising it to the 12th power, which is the same as doing root 2 to the 12th, and then we're going to add pi over 4 12 times, and that means we're going to multiply 12 times pi over 4, and we get 3 pi. Root 2 to the 12th is the same as 2 to the 6th. 2 to the 6th is 64. 3 pi, that angle's all the way around, and then 1 more pi, so it's in the same place as pi. The cosine of that is negative 1. The sine of it is 0, and that gives us a final answer of negative 64. Number 2, we're given the rectangular coordinates of a point. These are coordinates. This isn't the cis business. Okay, 3 pi over 4, so I draw that angle, 3 pi over 4. This distance is 6. Okay, this is one of those 45, 45, 90 triangles, and so this should be like 6 should be equal to x root 2, so these distances are 6 over root 2, which if you rationalize that, you get 6 root 2 over 2, which is 3 root 2. So both these distances are 3 root 2. We can see that the x-coordinate is negative and the y-coordinate is positive, and that's how we get negative 3 root 2, comma 3 root 2. Number 3, it says find the 3 cube roots of this number. So the first thing we do again is we write this number in complex form, in polar form. The x-coordinate is 4, the y-coordinate is 4 root 3. I should recognize this is like a 60-degree angle, or pi over 3, and that distance must be 8 then. And so we're taking 8 cis pi over 3 and raising it to the 1/3. And so I do 8 to the 1/3, and I multiply pi over 3 times 1/3, and I get cis pi over 9. Okay? I know there's going to be 3 answers all the way around the unit circle. And so each one will be 2 pi over 3 away from the one before. So 2 pi over 3 is 6 pi over 9. And so if I have 8, oh, this is not 8, these are all 2. So if this is 2 cis pi over 9, the next one's going to be 2 cis, well, I need to do pi over 9 plus 6 pi over 9 to get 7 pi over 9. If I add 6 pi over 9 to 7 pi over 9, I get 13 pi over 9. That's the third answer. If I add 2 pi over 3 to that, I get 19 pi over 9, which is 2 1/9 pi, which gives us the same value for sine and cosine of that answer. And so here I've got my answer. Okay, look at number 4. Number 4 is a trig identity type problem. The first thing is I have sine of 90 minus alpha. That is the cosine of alpha. The sine and cosine are complementary. Okay, so that's why it's called cosine. So one of the identities is that the sine of 90 minus an angle is the same as the cosine of the angle. And in the same way, the cosine of 90 minus an angle is the same as the sine of an angle. So if I simplify this part becomes cosine squared alpha. This part here becomes the sine of alpha. And then we have sine of the opposite of alpha. Well, sine is odd, and the sine of the opposite of alpha is equal to the opposite of sine of alpha. Okay, if I do some more simplification to just distribute that negative in, I get cosine squared alpha minus sine squared alpha. I should recognize that as an identity as the cosine of 2 alpha. All right, number 5. we're asked to find the sine of 2x. So the first thing, if I kind of think about what I'm going to do, I'm given the cosine of x. I should use the identity 2 sine x cosine x. That's what the sine of 2x is equal to. I'm given the cosine of x. I need to find the sine of x. Well, if you draw a picture, which I've got right here, it says that x is between 3 pi over 2 and 2 pi, so that puts it in the fourth quadrant. I can know that the x sort of coordinate of a point there is root 5, and the hypotenuse is 3, and then I can use Pythagorean theorem to find the y value, which is 2, and then I can write the sine as negative 2/3. And I can multiply that out, and I get negative 4 root 5 over 9. All right, number 6. Okay, you're asked to find the value of the cosine of alpha plus beta. So you have to know the identity. The identity of cosine alpha plus beta. All the cosines are cosine, cosine, sine, sine. And the SIGN is the opposite of what you're finding. If you're finding a sum, this is a minus. So here's the identity. We are given the cosine of alpha. We are given the sine of beta. Now I need to find the cosine of beta and the sine of alpha with the information that we're given. Okay, so we draw some pictures, which are drawn down here. This is a picture of beta. It says that beta is in the third quadrant, and the sine is negative 5/13. So that's where I get the 5. Here's the 13th, so this must be 12. And so the cosine of that must be negative 12/13. That goes right here. That's the cosine of beta. Now if I'm looking at alpha, here's alpha right here. It says that the cosine is 3/5, so the x over the radius is 3 over 5. That means the y-coordinate is 4. That means the sine is 4/5. Okay? Then I just do arithmetic. I get negative 36 65ths plus, because this is a negative times a negative, 20 65ths, and that gives me negative 16 65ths, and that's the answer. All right. Number 7. We're asked to solve this equation here. Okay, now you can look at that for a little bit, and one option would be to actually apply the identities for the cosine of 2x. That is not necessary, though. You should recognize that you can factor out a cosine of 2x, and that actually will be a much better strategy for doing this. So that's what I did. Factored out the cosine of 2x. Okay? Set equal to 0, so we can use the zero product property. And we can write two different equations. One is that the cosine of 2x is 0. And one is that 2 sine of x minus 1 is equal to 0. Okay, so I'll solve the sine one first. Gives me sine of x is a half. I use the unit circle to find those two answers, pi over 6 and 5 pi over 6. Okay? Now, the cosine of 2x is 0. Well, I think about where is cosine 0. It's at these two places right here, pi over 2 and 3 pi over 2. But I need to note that this angle is 2x. So if x is between 0 and pi, then 2x is between 0 and 4 pi. Okay, so I need to go around the unit circle one more time after pi over 2 and 3 pi over 2. So I get 5 pi over 2 and 7 pi over 2. Now that's 2x. So then how do I get x? Well, I divide all these angles by 2, and I get these 4 answers. So there are actually 6 answers to this question. And there they all are. Okay? All right. Moving on to the back. Here's what the final answer looks like. I'll sort of step it down here for you. First thing you should do is you should graph this where y equals 1 plus 2 cosine of x. Okay? The period of this is 2 pi. Okay? It's no different than anything. It's not changed. The period is 2 pi. So I make my scale by pi over 2's. My axis is at 1. I go up 2 and down 2 from that. So the highest I'll be is 3, and the lowest I'll be is negative 1. And cosine starts at the top, and so I graph that. Okay, so now if I'm going to take this and translate it into a polar graph, first thing I want to do is make a scale, and I'll just make it straight up. Okay? The first point I'm going to plot is an angle of 0 and a distance of 3. So that's going to be right here. Okay, so that red point here corresponds to this red point here. Okay, now, this point, pi over 2, 1. Well, that's going to be right there, okay? And at this part of the graph, I don't cross through the pole or anything like that, so I don't need to do anything fancy here. I'm pretty much just going to go like this, okay? Then here, pi negative 1, or negative 1 pi. So the angle is here at pi, but I need to go the other direction. So I need to put that point right here, okay? So there's that point, all right? And when I go from this point here to this point, I go through the pole. So what has to happen here is I have to kind of hook around and loop like that, okay? All right. 3 pi over 2 is the next angle. Okay, the distance is 1, so that's going to give me a point right here. All right, same thing. Between here and here, I have to go through the pole. So what has to happen here, again, is we hook around and we hit that point. And then finally, 2 pi is back at 2. It gives us right back where we started. Okay, so there we are. I think that's called a limacon. All right. Finally, a proof. Okay, just talking a little bit about this. Remember that we have to pick a side and work with one side at a time. So I picked the left side. I rewrote it. That's what you should do. And then I looked at it and I said, well, there's a lot of things I could do here, but I do notice that I'm going to have a 2 theta as my angle on the right side. So I'm probably going to have to apply an identity here somewhere. And I don't see an identity to apply, at least not right away. Okay, so I'm going to multiply out this. All right, so that's what all this becomes right here on there. We still have the minus 1 right there. So then I notice there's a sine squared theta plus a cosine squared theta. Well, that's just 1. So that's where this one came from. And I've got this one here. So those go away. And I'm left with negative 2 sine theta cosine theta over, and I went ahead and multiplied out the bottom because I did recognize that the bottom is cosine squared minus sine squared, which is the cosine of 2 theta. And now I've got the top, 2 sine theta cosine theta, that's the sine of 2 theta. So I've done what I wanted to do. I've made the angle 2 theta, and really I've got it, because now I've got sine of 2 theta over cosine of 2 theta, the opposite of that, and that's the opposite of the tangent of 2 theta. So that's the right side. So we did it.